So hello, welcome to the last thing I'm going to record for this class. I said I was doing a review for the final, and that is my plan. My plan is I'm going to do a little bit of just setup, kind of explain about the final tiny bit, and then I'm going to go through last semester's exam, which is on Vanco Hall. Solutions have been posted, the exam is there, but I'll work my way through it, and as I work my way through it, talk about things to expect, equations, and you know what you could see, what you should expect is coming. As a reminder, your final is Monday, May 10th. It is online. It is the same setup as exams 1 and 2. Opens at exactly 12:30, closes exactly at 2:45. I do ask you don't work together. If I find that you have the numbers do get randomized, if I find that you have someone else's numbers on your sheet, I will take that to be that you work together with someone and give you a 0 on the final, which will probably fail you in the class. Work on your own. The final will be 40 questions long, 8 pages of problems. The first page will be chapter 9. The second page will be chapter 10. The third page will be chapter 11. The fourth page will be chapter 12, and then it'll go 1 and 2, then 3 and 4, then 5 and 6, then 7 and 8. Any questions about the setup? Okay. Oh, yes. Was that a question?
And all good.
All right.
My bad.
It's okay. You don't need to have an equation sheet or anything, but I highly recommend you make an equation sheet of some kind. If you're flipping through all of the lecture notes during the exam, you're going to waste a lot of time flipping through all of the lecture notes. I really recommend make yourself a small cheat sheet that has the information you need to save yourself times flipping through everything. Okay. Study the homeworks, look at the old exams, and so on. I will be giving a periodic table and a series of constants. This says is the second page. You can rip it out. That's left over from when I did this in person. This would be like the opening page of the exam online, but there'll also be a link to this periodic table so you can get it separately. So it won't look exactly like this, but I'll have this information. As I said, I gave some links. Also, don't forget, you have one more homework due. It is due on Sunday night for chapter 12. Now, at this point, what I would normally do is the next few slides is going through all the equations for chapters 9, 10, 11, and 12. But instead of going through those, I'm going to start going through last semester's final, and I'll leave them up and I'll do them chapter by chapter. So if I get rid of this window, as you can see, the chapter 9 one is already up. Any question about the final in general before I start going through this? Okay. So the first page will, well, not counting that, the first page will be chapter 9. Chapter 9 was all about models of the atom. The big things that almost definitely you should expect to deal with is the energy of a photon, Bohr radius, Bohr energy level, and the Broglie waves. I could put on the Heisenberg-Ansoni principle. I sometimes do. I could put on stuff about the Bohr model of the atom, like what were the exceptions? What were the assumptions he made and things like that. I sometimes ask questions about protons, neutrons, and electrons. But those things I highlight in yellow are the big things. So what I asked last semester to break it off was, in a perfect world, we can charge our phones with Bluetooth, which is a type of electromagnetic wave. If Bluetooth has a frequency of 2.45 times 10 to the 9th hertz, that's a 2.5 band, how much energy does one Bluetooth photon have? If you want to find the energy of any electromagnetic wave, the energy is h times f. It'll simply be Planck's constant. Well, Planck's constant is 6.63 times 10 to the negative 34th joules seconds times the frequency, 2.45 times 10 to the 9th hertz. And you just multiply those numbers together. As I said, that'll almost definitely show up in some way, shape, or form. That being why did that not do what I told you to do? That equation right there. I will also always have some open-ended questions that aren't math, but you have to think about. Last time I said what color is the lowest in energy? The answer is red. I could do other things like the whole if 9 electrons relax, how many photons are produced. I've done that one before. I could do things about, once again, what assumptions did Bohr make. For the open-ended questions, it's kind of hard to study. I will always tell you what the math questions will probably be, but you can expect a whole bunch of things like that. What I also asked last semester, and I almost definitely will ask again, is what is the Bohr radius and what is the energy of an electron in a set state? That's question 3 and 4 respectively. Question 3 is what is the radius? If you want to find the radius of an electron in the Bohr model, the radius is given as 0.053 nanometers times n squared. That will be the process. So on this one, I said what is the radius in the 7th energy level? So it'll be 0.053 nanometers times 7 squared, which is 2.6 nanometers. This will almost definitely show up, but it's a nice and simple equation. There shouldn't be a thing you're upset is going to show up. It's just 0.053 times n squared. If you want the energy level is negative 13.6 eV over n squared, or negative 13.6 eV in this case over 7 squared, which is negative 0.278 eV. If you do not include the negative sign, I will take off a point, but this is also pretty straightforward. These will show up in some form. Don't be scared of them. Just plug and chug. Any questions there? I almost always work in a de Broglie. De Broglie equations are really easy to figure out are de Broglie equations because they will have the word de Broglie in it. If de Broglie shows up, you know what equation to use. Anytime I say anything but de Broglie, it's going to be that the wavelength is h over the momentum. Momentum is mv. If you see the word de Broglie, go straight to that equation. In this one, I said hydrogen atoms inside the sun have this mass, that speed. What's the wavelength? If I want to find those wavelengths, I'll just say it's h over m times v. Oops, that should be positive. And I'll get an answer. Any questions? That will be the first page, stuff like that. The second page will be all chapter 10. Chapter 10 has a lot less math in it. But what chapter 10 has a lot of is dealing with the periodic table. Now, as you know what, I will real fast. I'm going to go up. The periodic table, the link is the same as this one. I'm just going to open up the periodic table here so that I can just keep it open as I talk, although the tops are cut off on this. Oh, shit. I want to change the periodic table that's visible because this doesn't have the numbers on the top. It's cut off at the top. I will update that. So I don't know exactly what the periodic table is going to look like, but it'll look like that with the numbers on the top. I'll probably just take this one and manually re-add them. I'm sorry I did not notice that. Where did I just put that? I thought I just saved it. A good periodic table should have, as I said, I'll fix this. numbers written across the top of 1A, 2A, 3A, 4A, and as I said, I'll fix that. I did not notice it wasn't there on that copy. I don't know why it isn't. It was on this copy. So something must have happened when I moved it in. What you can expect though. I will ask for atomic number and mass number. Atomic number is the number of protons. On a periodic table, it'll be the numbers right next to each element. Mass number is number of protons plus number of neutrons. I might also do stuff with atomic mass. If I do stuff with atomic mass, that's the number underneath. That is how much one atom weighs in AMU. Type of metal, solid. That's going to mostly be metals, non-metals, solid, liquid, gas. I wouldn't expect too much there. Type of metal. That's the pure substances. Pure substances and mixtures. Pure substances is anything can only be broken down by chemical means, made up of elements and compounds. Mixtures are made up of homogeneous mixtures and heterogeneous mixtures. I might put that in. For periodic table, know your periodic trends. The periodic trends often show up. Chemical formulas will mostly be the naming of chemical formulas. Know how to do the names, both for ionic compounds and molecular compounds. And solutions, I normally ask things about either pure, what saturated, supersaturated, unsaturated, or homogeneous or heterogeneous mixture. So, this first one says a certain isotope of chlorine has 18 neutrons. What's its mass number? If I look at chlorine is atomic number 17. What that means is chlorine has 17 protons. Your mass number is always protons plus neutrons. And so if it has 17 protons and 18 neutrons, when I add those together, I get 35. Its mass number is 35. That's what mass number is. Mass number is always protons plus neutrons. Now, if I ask you how many electrons will always be the same as the protons. It's atomic number 17. It has 17 electrons. I will often also ask about valence electrons. If you want to find valence electrons, that'll be the name of the family. These numbers appear: 3A, 4A, 5A, 6A, 7A, 8A, and 1A and 2A on this side. Chlorine, right here, is in family 7A. So valence electrons is 7. Know how to get valence electrons. That will show up. And as I said, I will update the periodic table to have these numbers at the top. I apologize that it didn't when you were doing the homework. I thought it was there. You can see where like it was there and is slightly cut off at the very top. Like there's some numbers that are slightly cut off right at the very top. I don't know what happened. They used to be there. Don't know how they got cut off. Questions there? Okay, I also said there'll be periodic trends. I could do a whole bunch of periodic trends. We talked about metallic character, where metallic character goes up, down, and to the left. I also talked about atomic radius, where atomic radius also goes up, down, and to the left. We talked about ionization energy. Ionization energy goes the opposite way. Ionization energy goes up like this. Go through all the periodic trends. There is one slide that has all of them on it. This time I asked for the periodic trends of atomic radius. Once again, atomic radius is biggest the furthest you go down and the furthest to the left. And I say what has the biggest atomic radius between argon, krypton, calcium, and magnesium. But when I look at this, calcium is the one furthest to the left, and calcium is the one furthest to the bottom. And so it's calcium. I could do other periodic trends, just be ready for them. Okay. Any questions though? I normally do something with the naming of molecules. For the naming of molecules, that is that all Greek prefixes. If I do anything with the naming of Greek molecules, you have to remember the series of prefixes of mono, di, tri, tetra, penta, mono, di, tri, tetra, 5. Is then penta, hexa, I forget 7, octa, nona. Hepta is 7. Know your prefixes. Have them written down in front of you. I either will give an ionic compound and ask you to name it, or I'll give you the name and ask you to write it out. That way is probably easier. If I say carbon dioxide, it's CO2, carbon dioxide. If I go the other route, you do need to have that chart with you or have them all memorized, which obviously I don't apparently. Last semester, I went the other route. And I said, write out the name for N2I6. What you're going to do is you're going to start figuring what they are. I have N and I. N is nitrogen. I is iodine. However, when you name them, your second thing gets an "ide." See, I might be iodine, but in a compound, it is iodide. And then I'll just give them prefixes matching the numbers. There's 2 nitrogens, so it's dinitrogen. There's 6 iodines, so it is hexaiodide. And that's the compound, dinitrogen hexaiodide. I will not take off points for spelling as long as it's close. But as I said, I might go the other way. I might say dinitrogen hexaiodide, and you'd have to write N2I6. Any questions though? That is pretty, it's basically almost positive. You're going to have to solve for mass number in some way, or I'll give you mass number and solve for neutrons. It's almost positive they're going to have to solve for valence electrons. You're going to have to do one of the atomic trends. These will show up in some form one way or the other. I usually ask something about mixtures or the types of matter. Once again, pure substances are made up of elements and compounds. Mixtures have homogeneous and heterogeneous mixtures. They often show up. Last time, problem 10 was, what is a pure substance? It's a mixture of elements. That's a compound. Questions? Okay. The third page will be all about chemical bonds, because that's what that chapter was. In chemical bonds, there's a lot of things I can do. In chapter 11, before we started chemical bonds, like right before we did, we also talked about the law of conservation of mass. In any reaction, the mass of the products equals the mass of the reactants. That might come up. We also talked about mass ratios, where you could figure out the mass of a compound and what percentage of it is made up of various things. That will almost definitely show up. We talked about how to find the ionic charge of metals and nonmetals. You can expect that. We figured out how to work out what an ionic compound should look like. That's pretty likely. And also drawing molecules and what shape they are. The drawing molecules and what shape they are also pretty likely to show up. In fact, definitely likely to show up. I'm going to state right now for the drawing molecules, it's very obvious on the homework that a lot of you just Googled it without trying to do it yourself and blindly tried to trace a drawing you found online. It's actually kind of obvious when that happens. And a lot of you, because of that, lost points because when you just blindly copied off online, you were missing valence electrons. That most of the drawings have the shape, they don't show all the non-bonding electrons. Make sure when you do it, you actually do the work. You're more likely to get it wrong just taking offline and not understanding what you're looking at than just doing it. Because as I said, a lot of people, they just drew the shape without having all the electrons. And if you don't have all the electrons, I'm not going to give you all the points. It's because for the shape, you don't necessarily care what the electrons are, but I want a full electron dot diagram. So make sure you actually do the work. So last time I started with, what is the mass of one molecule of THC? Because why not? THC has this chemical formula, C21H30O2. If you want to find the mass of THC, we're going to have to add up all those pieces. You see, the mass of one molecule of THC is going to be 21 times the mass of C plus 30 times the mass of O plus 2 times the mass, a mass of H. I misspoke. Times the mass of O. It's 30H2O. Something like this, pretty likely to be on there. If I ask for the mass of a compound, just add up each element. And what I'll say is, okay, there's 21 carbons. Each carbon has a mass of 12.01 AMU. And you might be wondering, where the hell did I get that? Right here. It'll be the number on the periodic table. The mass at the bottom. Let's say 30, the mass of hydrogen. And I'll look at my periodic table and say hydrogen is 1.01 AMU. And 2 times the mass of oxygen. I'll look at the periodic table and say oxygen is 16 AMU. My email just popped up. And I'll just do that math. 12 times 21.01 is 252.21. 30 times 1.01 is 30.3. And 2 times 16 is 32. When I add that all up, I get 314.51. That is the mass of one molecule. Okay. I do sometimes ask for the percentage of the molecule. If you look at problem 12, I say by mass, what percentage is carbon? If I do percentage, I'll usually split it up into two problems where you basically do half the work here and the second half further down. I'll keep them related to make it take less time. That being said, if you get one wrong, it would be impossible, or you get 11 wrong, it would be possible to get 12 right. But if the only mistake you make in 12 is the mistake you made in 11, I'll still give you full credit on 12. But if you want to know what percentage of a compound is made up by an element, it'll be the mass of that thing, in this case, carbon, over the total mass, times 100 to make it a percent. And so what I'll say is the percent carbon will be the mass of carbon, which I found to be 252.21 AMU. And I would divide that by the total mass. That's pretty likely to be on the final. Just know how to add them up, know how to do the math. Okay. In things that are very likely to be on the final, and by very likely I mean will be there, number 13. I will ask you to give me the chemical formula for an ionic compound. Last time I asked aluminum sulfide. Define the chemical formula of an ionic compound. And I won't do a polyatomic here. What it's going to be is you have to find the charge of each one. Aluminum sulfide is the mixture of aluminum and sulfur, where aluminum is a metal. If I look at a periodic table, aluminum is a metal in family 3A. All metals, when they ionize, their charge will be the same as the number of valence electrons. And so when aluminum ionizes, it's in family 3A, has a charge plus 3. Sulfur is a nonmetal in family 6A. All nonmetals, when they ionize, they get a charge equal to the valence electrons minus 8. Now, it has 6 valence electrons, and 6 minus 8 is negative 2. So sulfur will have a charge negative 2. If I want to work out the ionic compound, that is that cross method. I'll take this 2 and drag it down here. I'll take this 3, drag it down there to get Al2S3. Questions there? I said this will almost definitely be though. Also almost definitely there, drawing electron figure. Number 14, draw the electron dot diagram for HCN. If you're going to draw a compound, your step 1 is going to be count the valence electrons. If I'm going to do HCN, that is a mixture of hydrogen in family 1A, carbon in family 4A, and N in family 5A. That whole valence electrons minus 8, that's out the window for this. I just want to know how many valence electrons. And so I have 1 plus 5 plus 4. Right? 4, 5, and 1. Well, 1 plus 4 plus 5 is 10. And so if I have HCN, I must have 10 valence electrons. How I'm going to draw it is I'll start by saying whatever the center atom is. And here's the goal. Everyone but hydrogen gets 8 valence electrons. They started with 1, 4, and 5 respectively. Don't fucking care. Everyone gets 8 except for hydrogen. Hydrogen gets 2. Everyone else gets 8. Started with 4, fuck it, it gets 8. Started with 5, don't fucking care, it gets 8. Everyone gets 8 but hydrogen. And what we'll do is we'll rearrange it so that everyone gets 8 but hydrogen gets 2. Start with your center atom. Put a C and surround it with the right number of dots. That right number of dots is 8 because everyone gets 8 but hydrogen. Now, you have to keep track of how many you had. I had 10, I used 8. I have only 2 remaining. Once you get to this point, attach your other things. In this case, a hydrogen and a nitrogen. And you can spread out your remaining ones where they're needed. Now, everyone gets 8 but hydrogen. Hydrogen only gets 2. Hydrogen has 2. We're good. It's my nitrogen that needs extra electrons. Now, when I look at this, what I can see is this nitrogen only has 4. And everyone gets 8 but hydrogen. It doesn't have 8. What that means is I have to give this nitrogen more. But I only have 10 electrons and I've already used all 10. I can't just pull them out of the ether. What I have to do is I'm going to take electrons in use elsewhere on the center atom and move them into the bond. I'm going to take those ones off the top and move them into the bond. By doing that, I do not take them away from C. C still has them, but now N also has them. And now my nitrogen has 6. But 6 isn't 8, so no one fucking cares. It needs 8. So I'll take these 2 off, and I'll do the same. And that's the structure. Now, as I said, a lot of people I know on the homework very obviously cheated because I saw a lot of things with people doing this. And that's all they put. Maybe they did that. They didn't even have the letters on it. They didn't have these extra dots because they just Googled and took the first image. That's stupid. Don't just Google and do the first image. Do the fucking work. A lot of people lost points for that. That will be on, though. You will be drawing something. Now, what I normally do when you draw it is I ask 2 questions. What is the shape? And if there are no polar covalent bonds, what would be the polarity? A lot of people got that bit wrong because once again, that assumption, if there are no polar covalent bonds, is a weird assumption to make. And so a lot of people Googled it and got it wrong because there was polar covalent bonds despite me making that assumption. To work out the shape and whether or not it's polar, go to this table from the notes. What you do is you look at the center atom and you say how many things are bonded on the center atom. This center atom has 2 things bonded on, hydrogen and nitrogen. So I have 2 bonded atoms. You then say how many lone pairs are on the center atom. Now this center atom has no lone pairs on it. And so there's the answer. The answer is linear and nonpolar. Any questions? The next page will be chapter 12. Things you should know. What are chemical changes? What are physical changes? What are chemical properties? What are physical properties? How to tell if a chemical reaction occurs, right? Color change, heat or light produced, gas produced, two liquids make a solid. I cover that in class. Also know, what does exothermic mean? What does endothermic mean? Know the relationship between moles and molar mass. That'll probably be at the end. But one of the big ones is the equations. We talked about 5 different types of chemical equations: combustion, decomposition, combustion, double replacement, single replacement. I will not give you a problem with decomposition because those aren't predictable. But for the other ones, I will give you the product. Sorry. I'll give you the reactant, and it'll be on you to finish the reaction and balance it. I'll start at the top though. What do we call a reaction that produces heat or light? Produces heat or light? That's exothermic. Exothermic means produces heat or light. Endothermic means takes heat or light. As I said, that's kind of one of the open-ended ones, they're hard to study for. I might instead do stuff about what proof of chemical change or what's a chemical property or something like that. 17. Create and balance the reaction for the complete combustion of pentane. There's 4 types of reactions I could ask for. Combination, combustion, double replacement, single replacement. Which of those you're going to get, you don't know. Probably it's going to be 2 of the full. It probably won't be all full, but they will be on there. If it's a combination, I'll give you 2 separate things. You just put them together, but watch the ionic charges. If it's a single replacement, you replace the cation and the lone metal, but watch the ionic charges. And if it's a combustion, like this, any combustion reaction will always be the thing will react with oxygen. And after it reacts with oxygen, it'll produce carbon dioxide and water, where everything is a gas. Theoretically, there should be a triangle right there, but I won't take off points for not having that. If I do a combustion, it'll be whatever I give you and just O2, CO2, H2O. The only real trick is the balancing. There's 7 carbons. That means I need to have 7 carbons here. There's 8 hydrogens. That means there needs to be 8 hydrogens here. Now I'm only going to put a 4 because it's 4 times 2. Now when I do that, that turns this guy right here into 14 oxygens and this one into 4 oxygens, which is 18 oxygens. So I need to have 18 oxygens. That's the correct answer. Questions? Okay. Double replacement. That's the next one. I say do the double replacement of BaCl2 plus K2CO3. For a double replacement, start by collecting everything. Barium chloride is a mixture of Ba with a charge +2 and Cl with a charge -1. If you want to know where I got these charges from, the answer is the periodic table. This whole the stuff from last chapter. I'm mixing that with KCO3, where K has a charge +1, CO3 has a charge -2. Now the CO3 isn't immediately obvious. I would need to pull that from a table of them. This was in the notes, but like CO3 has a charge -2. And what you do is you swap the cations. So afterwards, I'll have K +1 with Cl -1. and Ba plus 2 with CO3 minus 2. And doing the cross method, that'll be KCl. And these are both 2, so they cancel. BaCO3. Now, I did say to include phases. Oh, wrong thing. I thought that was chapter 8, but it's not. I gave in class a list of what I called the solubility rules. And the solubility rules is how you will work out the phases. Here it is right there. Anything that fills one of these categories will be aqueous. The other one will be solid. And this is anything that starts with a K is aqueous. So there's my phases. I also need to balance. There's 2 chlorines, so I need to have 2 chlorines. And there's my answer. These are the this page is traditionally the one people do the worst on in this exam. I'll be honest. But predicting the reactions is a pain in the ass. But that is the process. As I said, I might also do combination. I might also do single replacement. Any questions though? Okay. A shot glass of ethyl alcohol has 4.54 times 10 to the 23rd molecules. How many moles? You can expect this. The relationship between moles and molecules. The relationship between moles and molecules is moles is the number of things over Avogadro's number. So if I want to know how many moles, I would just say it's 4.54 times 10 to the 23rd atoms, or molecules, I should say, over 6.02 times 10 to the 23rd. And I'll just do that math. I might instead give you a number of moles and ask for how many molecules. If I do that, you multiply instead of divide. Okay. I normally also work something with molar mass. And that's what 20 was last time. How many moles is 5 grams of butane? If I give you a mass and ask for the moles, what we can say is that mass over molar mass is number of moles. That moles is mass over molar mass. I might instead give moles and ask for mass. If I do, it's moles times molar mass is mass. So I want number of moles. I'll just say it's 5 grams over the molar mass. But I didn't give the molar mass. I said it was butane, C4H10. But I can get the molar mass of butane. Butane is C4H10. Therefore, the molar mass of C4H10 is 4 times the molar mass of C plus 10 times the molar mass of H. Well, molar mass is the same number as atomic mass. So I pull up my periodic table. Well, I say pull up because I threw it on the ground. And say the molar mass of carbon was 12.01. The molar mass of hydrogen was 1.01. Once again, that's off the periodic table. That number is 58.14. And so that's what I put for this number. And there you go. Questions? Okay, we're 40 minutes into this time period. I don't know what you guys actually want from me. So here's the setup. After this, it's all old stuff. This page is chapters 1 and 2. This page is chapters 3 and 4. This page is chapter 5 and 6. This page is chapter 7 and 8. And it's very similar to what you saw on exams 1 and 2. Would you guys like me to just keep going and go long and go through these other pages? Or do you want to say we've saw this stuff before, we understand the type of things? I'll let the people in the room decide since you guys came. What would you rather?
I think since we've already done that stuff and like taken tests on it, we could always go back and look at the old questions
Okay.
just as a refresher and
I
like our notes too. So
Okay. I will say the solutions to this all online. So I mean you can look at the solutions too. Is there anyone do any of the other either of the two or the other of you want me to go through it?
No, I'm good.
No, I agree that we
Okay.
already did it.
Cool. I will happily stop there because my allergies are acting up again today. I just want to blow my nose. That's the kind of stuff to expect. As I said though, I will say this again. It's not just old stuff. I do split it up chapter by chapter. So it will be 1 and 2, then 3 and 4, then 5 and 6, then 7 and 8. You can see this exam online. You can see what I did before. Expect kind of similar things. I mean, I, 1 will be with unit conversions. 2 will be free fall and something else. 3 will be F equals ma. 4 will be energy. 5 will be heat and this thing. 6 will be waves. 7 will be a ray diagram or a lens diagram. And 8 will be resistors in parallel or series. That's the big hint I'll give. But other than that, I will stop there. I hope you all have a very good weekend. If you have any questions on that last homework, feel free to email me. But otherwise, the final is on Monday. I hope to have it graded by end of day Tuesday. There's a good chance I'll have it graded end of day Monday because I have a second final on Monday and I have plans to grade your final while proctoring the second final. I'll email you when the grades are up. But once the grades are up, that is the final grades in the class. I do not do extra credit or anything. But you can always ask me if you think I made a mistake grading because sometimes that happens. But other than that, we'll stop there. Have a good day.